Hey guys, I'm back with another Laplace transform question from September 2020 exam. So before going to solutions, please subscribe to the channel. Okay. So the question is find the Laplace inverse of this function using convolution theorem. Okay. So if we had a function like this, f of s is equal to s over s square plus a square. So what is inverse Laplace transform of this function? I know if you take inverse Laplace transform of this function L inverse, you will get cos at. S over s square plus a square inverse Laplace transform is cos at. Okay, and f of s inverse Laplace transform is f of t. Okay, so what do I have here? I have s square over s square plus a square, s square plus a square whole square. So I have two of these multiplied. Okay, so that's what I have to find the inverse Laplace transform of. But I know the Laplace inverse transform of this also is cos at. Okay, so if two functions are multiplied in the Laplace domain, can I multiply their Laplace inverse transforms? Can I write f of t is equal to cos square at? Okay, so that's what convolution theorem talks about. Okay, so if you have here f of s is equal to, there are two functions, right? So I'll call this function as g of s, I'll call this function as h of s. Okay, if I have g of s into h of s in the Laplace domain. Okay, something's Laplace transform is this. Okay, so what is inverse Laplace transform of this? It's not, so this is, if this is g of s, this is g of t, right? And this is h of t. So if you take inverse Laplace transform, they will not, you cannot multiply them. The product here becomes convolution between g of t and h of t. G of t convolution h of t. Convolution is represented as a star. Okay, so that's what convolution theorem says. Convolution theorem says convolution here becomes multiplication here, multiplication here becomes convolution there. So what is convolution defined as? So g of t convolution h of t is basically integration g of u into h of t minus u with respect to u from u is equal to 0 to t. Okay, so if we so I can write g of s into h, f of s is g of s into h of s, so f of t will be g of t convolution h of t, cos at convolution cos at. So what is convolution? Convolution is basically integration from 0 to t, multiply these two functions after replacing t with u and t with t minus u. Okay, so this integration is convolution. So if you want to find the Laplace inverse transform of this product, take individual inverse Laplace transform and integrate them in this manner. So what do I get? If I integrate, so f of t is equal to integration from u is equal to 0 to t. In place of u, in place of t, I have to substitute u, g of u, right? So g of t is cos at, so g of u will be cos au. Okay, into h of t minus u. H of t is cos at, h of t minus u will be cos a into t minus u with respect to u. Okay, so this is all convolution theorem. Convolution theorem ends here. Only you have to split the given function into two functions and take inverse Laplace transform of individual functions, which are easy by the way, and then take convolution. Convolution is integration this and this. From this point onwards, it's integration question. So how do you integrate cos into cos a into cos b, right? So I know cos a into cos b is, you cannot directly integrate this. Okay, we have to convert this to only one cos term. How do you do that? So cos a into cos b is 1 by 2 cos a plus b plus 1 by 2 cos a minus b. Okay, this is what I know from trigonometry. So if I substitute this here, what will I get? Integration f of t is equal to 1 by 2 integration from u is equal to 0 to t cos a b, cos a plus b, right? So that will be cos a is au plus b is at minus au, at minus au with respect to u plus this 1 by 2 integration from u is equal to 0 to t cos a minus b. So that is cos a is au minus at minus au, minus at as it is, minus au is plus au with respect to u. Okay, so now we need to solve this integration to get f of t. Let me make some space here and we'll solve this integration. F of t is equal to 1 over 2 integration from u is equal to 0 to t cos au minus au is 0. So cos at, integration cos at with respect to du. This is very important. Whenever you see integration cos, it's not always sin at by a. Okay, it's if you have to check what is the variable you are integrating with respect to. Okay, so here it is plus 1 over 2 integration u is equal to 0 to t cos au plus au is 2au minus at into du. So what do we know? We know integration cos at is equal to at with respect to dt is equal to sin at by a. So the coefficient of t comes in the denominator. So here cos at, we have to integrate cos at, but with respect to u. So in this case we have to consider cos at as constant and keep it outside. Okay, so this is equal to cos at by 2 keep outside. What is integration? Du, integration 1 du. What is integration 1 du? It's simply u from 0 to t limits. Again plus half. Here we have to use this formula. Here the coefficient of t is a, right? Here the coefficient of u is 2a. Okay, so what you have to do is integration cos 2au minus at is sin 2au minus at divided by whatever the coefficient of u that you have to write here from 0 to t. Okay, so if you evaluate the limits, how do you evaluate limits? Upper limit minus lower limit. So in place of u, if you substitute upper limit t minus 0, t minus 0 is t. So this function will be t times cos at by 2 plus half. What will you get here? First let's substitute upper limit. So that is sin 2at minus at. If you substitute t in place of u, it is 2at. 2at minus at is at by 2a minus, substitute 0 in place of u, you will get sin 2au is 0 minus at is minus at over 2a. Okay, so we know sin of minus theta is minus sin of theta. So sin of minus at is minus sin at. So minus and minus becomes plus. So sin at by 2a plus sin at by 2a is 2 sin at by 2a. Right. So finally what I get here is f of t is equal to t cos at by 2 plus sin at by 2a. Okay. So this is the Laplace inverse of this function. How did we find that? We used convolution theorem to find that, because Laplace transform of inverse Laplace transform of individual functions cannot multiply, so we have to use convolution. Okay, so multiplication here is convolution there. So convolution is integration. Integration is this. This is how you find inverse Laplace transform using convolution theorem. So if you want to learn more about, if you want to solve more questions on convolution theorem, and if you want to learn how to integrate the functions like this, please visit our course that we have done on VTU M3 syllabus. The link to the course is in the description.